In this video, we will transform a function graphically using written transformation rules. The example is, find the function that is finally graphed after each transformation is applied to the graph of f of x equals the square root of x. So we want to shift that curve up 2 units, then reflect it about the x-axis, and thirdly, reflect it about the y-axis. When we're done, our graph should reflect or should denote all 3 transformations, and our equation will be the result of the 3 transformations. We'll start with the parent function, y equals the square root of x. I'll choose convenient values of x, such as 0, 1, 4, and 9, because those are all perfect squares. Now I'll graph the function, which looks like this. That's the function y equals the square root of x. Now the second thing we want to, or the first thing we want to do really for transformation's sake, is to shift it up 2 units. So symbolically, it looks like the square root of x plus 2. In the table, we can take all of the x values, keep them the same, and add 2 to the corresponding y values. So at x equals 4, y will equal 4. At x equals 9, y will equal 5. Now we can graph the square root of x plus 2. And you can notice with your eyes, you can verify that that is just the parent function, the square root of x, shifted up 2 units. Now when we reflect about the x-axis, symbolically that means we want to negate our previous expression. And with the table, what this means is it was the previous table values, but just with the negative or the opposite y value. When we graph that, we're expecting the mirror image of the previous graph. All right, our third transformation says to reflect this curve about the y-axis. Now when we reflect about the y-axis, we want to think about putting a negative sign in front of the x. And according to our table of values, 0 will work out fine, but I have to use -1 as my input because of the fact that to take the opposite of an x value and then the square root it, I need positive numbers, remember, in front of, in my radicand. So at x equals -4, my y value will be -4, and at x equals -9, my y value will be -5. So I can graph that, and I'm expecting a reflection across the y-axis. Okay, so let's summarize what we did together. We started with our parent function, f of x equals the square root of x. The direction said to shift that up 2 units. So we can see visually and symbolically, to shift up 2 units, you just do +2 outside of or past the parent function. And then we reflected across the x-axis. We remember what that looks like. And symbolically, you're negating your y value. And to reflect something across the y-axis, you're negating your x value. So my final answer to this question is taking the parent function of the square root of x, after shifting it up 2 units, reflecting it about the x-axis, and then reflecting it about the y-axis, my final symbolic form of the equation will be y equals negative the quantity square root of -x plus 2. And graphically, it will be that last curve which is mapped in orange.